Let's look at one very similar to number 41E. The ones in 41 ask you to find a formula for the function, in this case in terms of x, and you see the function is determined or defined by a definite integral from 2, in this case, to x cubed. Notice x is our very independent variable for our function. And so the integral from 2 to x cubed of this function. Notice the variable of integration is t, right? You can see that from the dt. And that's real important, that if you're doing a function defined this way, this variable here of integration, in this case the t, cannot be the same as x. In other words, I couldn't do 7x plus 5 dx. That would not make any sense, having your variable of integration being x as well as having that variable in one of our limits of integration. So you have to have a different limit, variable for the integration process. Okay, so that's the way it's defined. So what do we do here? Well, first of all, we're going to use the fundamental theorem of calculus part 1. We're going to find the antiderivative of 7t plus 5. And so I hope most of you are really good at getting the antiderivative. So the antiderivative of 7t plus 5 is 7/2 t squared plus 5t. Of course, that comes from the fact that if I do the antiderivative of 7t, what happens? The 7 comes out, and then the antiderivative of t is what? By the power rule, add 1 to the power t squared over 2. So 7 times t squared over 2 is 7 divided by 2 times t squared. And of course, the antiderivative of 5 is 5t. So that polynomial function should be pretty quick for you at this point. And then what do? This is I call this capital F of t. This is the antiderivative of little f, right? And so what do? We evaluate it at the upper limit minus the lower limit. Make sure you get that order correct. I mean, that's a common mistake, is to flop the order that you're subtracting. So it's always the upper limit evaluated, right? The antiderivative evaluate the upper limit minus the lower limit. Okay, and so I just plug those in, and then I evaluate. Just a couple of reminders: when you take an exponent, x cubed, and raise it to another power, remember what happens? We multiply those powers together. So it's going to be 3 times 2 is 6, not 3 plus 2. And the way to think about it, if you think about x cubed squared, is what? X cubed times x cubed. X cubed is 3 x's multiplied together. So you got 3 x's multiplied together, and 3 x's multiplied together gives you 6 x's multiplied together. And then we just simplify things as I've shown here. Be real careful with this negative sign right after I evaluate this to be 14 plus 10 is all 24, becomes minus 24 there. So there is our final, scroll down, sorry. There is our final result for this function. So this is the new function f of x. Okay, and again, as we're looking at this section, these types of functions occur when we're looking at the so-called area accumulation functions, and we'll look at some more examples of this in this section. So I hope this helps. We'll look at some more later.